a longtime Boulder Ruby member, and he's the founder of the Alchemist Collective. And there he works on writing, speaking, and teaching about the joy of the craft of software engineering. So tonight he's going to talk about Ruby pattern matching. Take it away, Brooke.
Thanks, Dan. Let me do the correct thing and share my screen here. Oh, apologies. This is the first time sharing with Zoom, so I gotta set my preferences. Oh wow, I should have done this beforehand. This is hilarious.
Quit Zoom actually, and has been my experience. But good luck.
Okay, let's give this a shot. And Dan, just scream at me if you don't see anything. So, all right, how does that look? Can everybody see my screen? I guess.
Yeah.
Okay. Awesome. So yeah, thanks everyone. I'm super excited to talk about Ruby pattern matching. As many people know, as Dan said, I love talking about Ruby. Anything Ruby always brings me a ton of joy. But tonight I want to dive into Ruby pattern matching. And what I want to do is take a deep dive into this, talk about all the aspects of this, because it's a really powerful tool, but it's also a little complicated. And I want to point that out to you, but also level you up so you can actually walk away from this talk and have a better understanding of how to use Ruby pattern matching and bring it into your code. So before we start, though, I want to do a little bit of a history. Just briefly, this was introduced as an experimental feature in Ruby 2.7, but luckily with Ruby 3, it's actually full-fledged, right? You can use this, it's not experimental anymore. There are some aspects of it that are still experimental, and I'm going to point that out to you as we talk through this a little bit more together. So one of the things that I want to talk about is kind of an overview of all the things that we can do with pattern matching. So there's a standalone syntax, we'll get into that in a bit. There's a syntax for matching against arrays, hashes. We can do remainders. We can do finds. We can also do voids. We can do some really cool stuff with variable binding. We can also do combinations in our pattern matching. We've got guard clauses, and we can teach our own objects to be deconstructible so that we can pattern match against our own Ruby objects, which is super cool. So let's kind of walk through the syntax here a little bit. And I want to start off with standalone syntax. This will be a little foreign at first if you haven't been playing with it, but I'll show you what I mean, and then we'll dive into it more together as we go deeper into these slides. So first off, the standalone syntax is just a one-line expression syntax. At the top here, if you use in, which is the new keyword, you can get a true or false Boolean type pattern match, right? You can have an expression, you can match against a pattern, and it'll come back as a true or false. The other thing that's really cool that you can do is you can use a hash rocket, and you can actually assign the elements of your expression that you're trying to pattern match against to variables and use that data for further processing. So what does that look like? Well, if we take this case right here, where we have a hash and we're pattern matching against this key value, right? Well, actually just the keys. So we're taking the character and we're getting the last name. And the way that we're going to do this is we're going to assign the last name to the value that's in the hash. And we're going to do that through a hash rocket. So Reynolds in this case is going to be populated with last name in this case. That's what this pattern is matching against. So when we finally do the put statement here, we've got a local variable pinned last name for that key, and it's printing out last name Reynolds in this case. Now, don't worry about all this. We're going to dive into the specifics of this more as we dive deeper into this, but that's just kind of the overview of standalone syntax as one-liners. This is experimental. So what I mean by that is you'll get a warning each time you try to run this code in your console or in your code itself. So it's really fun to play with, but you might not want to use that in production just yet.
Hey,
the
Brooke,
other aspect is,
I'm sorry, if we have questions, should we save them for the end?
Oh, yeah, thanks, Dan. That's a great question. Actually, just feel free to stop me at any point. I don't mind being interrupted, or people can just ask anytime they want. Yep.
And I had a question on the previous slide. It was a self-serving moderator question. Can you go back to the previous slide real quick? And I was curious, the last name that you have in the puts, or puts, whatever it's called, is that variable defined because of the last underscore name on the left-hand side or the right-hand side?
On the right-hand side, yes, good question, Dan. Yep, it's on the right-hand side. And in fact, actually, as we dive deeper into this, I'll show you what's happening there. So we'll talk about this a little bit more as we get deeper. Yep, yep. So here, let me skip ahead to my slides here. So, okay, so in the standalone syntax, we can also use in, right? And the way this works is this is a way to actually do a Boolean check. So here I have a hash, right? Or sorry, an array, but I have an array of hashes. And they're both kind of structured the same way. And I'm going to do in this basket, right? I'm going to ask it, hey, does any of these match this pattern? And the way that we're going to do this is we're going to say, hey, fruit is the expression, in is the check that we're going to do against the pattern, and we're going to match against the key that has a value of app, which is a regular expression. So what's really nice about this is going to spit out true because we're just asking it, hey, does any of these fruits in our basket, does any of them match? And in fact, they do. And the reason they do is because Apple matches the APP in the regular expression, but Peach does not. And so it comes back as true. So this is a nice way to have a one-liner to actually use a pattern match to check to see whether we have something or we don't. So pretty cool. Again, that is experimental. Now that we've kind of talked about the standalone syntax and the nature of that, let's actually dive into the case statement, which is not experimental. And you can use this today in your Ruby 3.0 code. So let's take a look at the syntax here. The way this works is you have a case expression like you've always done it in Ruby before, but something new is happening where you can have an in and then a pattern and then do a then and do your evaluation. The other thing too is you can't mix ins with whens. If don't try it. If you do, that's going to just end in frustration and you're going to be very unhappy. So you can't have your case expressions, your logical control flow mixed with your pattern flow. Now, in the pattern flow, the way this works is in your case expression, what Ruby's going to do is it's going to kind of chunk through these one by one and try to find a pattern. If it doesn't find a pattern match and you don't have an else statement, it's going to give you no pattern match error. And this is awesome, by the way. And let me explain why. So in order to do this, we kind of need to compare expression flow, control flow versus pattern matching. On the left, we have control flow like we've always done before. But nothing happens when we don't have an else statement there, right? In Ruby, it'll just come out and it won't do anything, right? You might even have a nil, or you could have a kind of a bug that is not taken care of. And this kind of sucks that Ruby doesn't do this. But in pattern matching, though, if you get through all those patterns and you don't have an else there, it's going to throw no matching pattern error, which is fantastic to keep our code more robust and resilient. Now, I do want to point out that in Ruby, especially with Rubicop, you can turn this style on. If you enable this style, which I highly, highly recommend doing, this will force everyone to write code that you always have an else to your case statements and your if else then logic, or if control flow. Highly recommend turning that on. So now that we've kind of talked about the syntax at a high level, let's dive into this a little bit deeper and let's talk about the primitives, the support for pattern matching in primitives, especially with arrays, hashes, and structs. So at first here, here's just some lightweight syntax, right? Where we're matching on an array and and a hash, right? And don't worry about all the syntax here. We'll dive into this more together. But what you can do is it's optional to have brackets for arrays and braces for hashes. You don't have to have them, but it's kind of nice if you don't, because it just reads a little bit better. There's less typing. It's just more elegant. And that's the beauty of Ruby at the end too. Now, the thing I want to point out here is it is required for standalone syntax. So the standalone syntax I was showing you earlier, you do have to write it with the braces and the brackets. There's no way around it. But when you're using case statements or case expressions, it's optional. So let's talk about whole versus partial matches. This is really important. And the reason I want to highlight this is because it kind of tripped me up when I was first getting into this myself and didn't realize the power of this. It was kind of a subtle thing, and I want to point it out to you all. So with arrays, when you're doing pattern matching, they're always a whole match by default. which means all of the pattern that you're going to check against your array has to match or it won't work. So in this case, we actually come back as unmatched because we are only checking against a pattern of 2 integers in this 3-element array. That's why this is not going through. Now, the other thing to point out too is order matters. Because of the nature of arrays and because they are whole pattern matching by default, you're going to want to make sure that your arrays are sorted. Otherwise, you might be hating life, especially if you don't have the same elements like integers across the board. Maybe you have a mix of like symbols, strings, floats, you name it. You're going to want to make sure those are in the right order, or you'll not be happy with your patterns. With a case of hashes, with hashes, this is a match in this case, but you'll notice that we're actually doing a partial match, which is way different than the array. We're able to say, hey, if a key has an integer value in it, then that's totally cool. It's a match. We're good to go. It matches our pattern. Even though we have B and C keys in that hash, we still get away with it. Really important to note the difference there. There's an exception, though, with hashes that I want to point out. Is if you look at this piece of code, these 2 pieces of code side by side, you'll see that we're matching against a hash that's filled on this side, and it's actually going to come back unmatched because we're matching against a pattern that is an empty array, and that's really critical. That's the caveat here. And then with the situation where we have an array that doesn't have any content in it, that's going to come back matched in that case because the pattern and the element or the empty array or empty hash, sorry, that we're looking at is matched in that case. Now, moving on to finds, there's some cool stuff that we can do with arrays only that is not possible with hashes. And that is that we can find within an array. And the way that we do that is we do that with splats or stars. And what we're matching against here is just 2 symbols that are inside this array, but we don't care what's on the front of the array and what's on the back of the array, which comes back as a match, which is really, really nice. This is expensive, though. I just want to highlight this. Not only is this experimental, and you'll get a warning in your code when you're running this, but the Ruby core team does recommend that this is actually an expensive operation, because if you have a large array and you're trying to match something kind of within that array, it takes a little while for it to process and pull that back. I don't know what the benchmarks are on this. I would like to run some more of this myself, but just be aware that this is not only experimental, but expensive. Something else I want to point out here too is while we were looking at that example, we can also name our splats. And this is pretty cool, where we're doing a find like we were doing on the first slide, but we can also give those names and we can do something with them. So in this case, I just said, hey, for those first and last outer edges of the array, I want to give them a name. So that's variable pinning, which I'll talk about a little bit more in some future slides here, but we can print all that out. And that's why we get the A and the 1 and the 2 in the output here, which is pretty cool. We can also do voids. So this is special with hashes only, not arrays. And the way this works is we'll match on the whole hash here. And you might be thinking, hey, that's kind of weird. This pattern where I have the nils, the second one matched, why is that? Well, what's happening is you got to have these at the end of the array or end of the hash. That's the only way it works. But the way this works is if you remember when I was showing you kind of how arrays are whole value, whole pattern matches, and hashes are partial matches by default. Well, with this technique, by using nils, this basically forces hashes to work like a whole pattern match like an array does. It's kind of subtle, a little tricky, but what's really nice about this is if I had a third element, so I have keys A and B here, but let's say I put in C, well, normally it would still match on what you're seeing, what I'm highlighting here, right? It would still pattern match. But with the nil, it says, hey, buddy, this needs to be just these 2 elements and nothing more. If there's anything else in there, that totally does not match, and you're going to get the else statement in this case. So I just want to highlight how powerful that is. It's really, really cool. So we can also do things with remainders. The way this works in both arrays and hashes is we can use splats again. In the case of an array, it's just a single splat. and that'll give us a match, right? That gives us the power to turn arrays who are normally whole value pattern matching. Now they can become partials through the power of the splat. With hashes, this is actually kind of silly because we could actually get rid of these splats, these double stars here, and it would still match, right? It's just because, again, the nature of a hash is it's partial matching by default. So this actually doesn't gain us a whole lot here, but I just want to show you the difference. That's why I'm highlighting it. And in this case, we also still get a match. Now we can name these later, and I'll show you that as well. But first, let's talk about variable binding a little bit more. I've been kind of hinting at this and kind of dancing around this, but let's actually dive into this a little bit more. So one of the cool things is if we want to match, in this case, in the array, an integer, we can actually give that integer a name. And now we have a local variable first, which we can then use and print out later. So in this case, it's going to give us matched number 1, right? In the case of the hash, same kind of syntax, except we just have, the hash key type syntax. And then we use a hash rocket to assign it to the first variable in this case. And that prints out a match result for us as well. Now, we can simplify this a little bit further where we might not care about the type. So in that first slide I was showing you, right, we said, hey, if the integer is in the first position, we'll name it first and then we'll print it out. Well, we can do something else that's kind of cool here too, is we can say, hey, I don't actually care what's in the first position, what kind of type it is. I mean, in this case, we have 1 and 2, right? But it could be a symbol, it could be a float, it could be a string. In this case, we don't actually care about the type. We just care that we have something in the first position and we're going to print that out, which is really nice in case you want something that is a little bit more ambiguous and you don't know the type. Same thing with hashes, right? In this case, we're just naming the A key, kind of almost renaming it as first and then printing that out. This actually, as just an aside, is kind of funny because if some of you are aware of doing like transform keys in Ruby through a hash, you can kind of do this through pattern matching, where you take each one of the keys that are coming in through your incoming hash and you can rename them this way using pattern matching. Just sort of a fun aside, but I just wanted to highlight how valuable this is. And again, you get a match, same here as well. So there's one other thing I want to point out is this is special to hashes only, but you also get this even more concise intersyntax, which is if you don't want to rename the key and you just want to take the keys that are coming in from the hash that you have in this case, you can still use that key and print that out. And that'll give us a match as well, right? And we can print that out. So if you love the keys that are coming in and you don't need to rename them any other way, then you can just use them as is and you'll have that local variable available to you, which is pretty sweet. So there are cases I want to point out where you might want to do something a little bit more complicated, right? Where you have an array and you have a hash, but they're kind of nested. They have things within them. So in this first example, when we do this, we have to use explicit brackets. So if you remember when I was telling you earlier that the brackets and the braces are optional, well, they have to be a little bit more required in this case, because when you're doing nested pattern matching, you need to be explicit in order to teach Ruby what that pattern looks like. And so you have to bring back that syntax. So in this case, I'm just looking for something that matches within the array, the first position, and then something that's a string, and then I splat out the rest. I don't actually care what's in the rest of the array. And then I just print that out. And so we get what the value of first is in this case, which is apple. And same thing for the hash. So we can also do remainders, right? And this is what I was hinting at before. When I was talking about those splats, we can also actually assign those to a name and do something interesting with those. So in this case, in the first case here on an array, I have a remainder, and I just want to capture not only the first position, but I actually want to gobble up the rest of the array and print that out as well. So when we do that, now we have the first in the first position, and then we have the remainder of the array, which comes out as a subarray here with the elements 2 and 3. Same thing with a hash. When we gobble this up, we can actually pass this on and do something interesting with it later. And there's been cases where in pattern matching, I actually not only need to check for the A key in this case that's coming through and do something with it, but I also want to send off the remainder for further processing. So this is a nice way to chunk up that and split that data into something I can do something more interesting with. And again, if we print this out right, we get the number one, the value of the first key, and then the rest of the hash gets split out for us in the remainder. So you can also do conditionals in this case. Now these examples are just a little contrived, but they're kind of nice to show off some differences here. So the way that we get away with doing conditionals is using the pipe operator. So in this case, what we're doing is we're saying for the array, we're saying if it's a symbol, if it's just an array of one symbol only, then great, it's a match. But if it's an array of a symbol, integer, and float in this case, then it's also a match. And that's why we get a match in this case. But it would totally work if we had a one element symbol as well. In the case of the hash, we have something a little bit more funky going on where we're saying, hey, as long as it's an A key with an integer type in it, it's a match. But we would also be fine if it was just an array as well, and that would print out as a match. So here we're dealing with two types totally together, right? That is interesting from a sort of development perspective, right? When you're kind of dealing with two types like that, that's makes me kind of wonder if you've got some bad data coming in. But it's nice to know that you can actually do something like that in Ruby. So in the case of hashes, there's something else I want to point out as well, which is you can actually do this kind of syntax where you try to do a conditional where you have the A key and then you want to do an array, but this will actually give you an illegal variable syntax error. You can't do this. This is illegal Ruby code. But you can actually get away with doing this, where you put the A key and then you just don't care what the value is by using an underscore. The Ruby team actually recommends not doing this because the whole purpose of using the underscore is to basically gobble up the value and throw it away. You don't actually care what that is. And it's meant to be able to pattern match against something and not care about the value. So don't do this, even though it technically is possible to do this. But as a practice, as a style guide, try to avoid this if you can. So let's dive into variable pinning just a little bit further, right? We've been kind of talking about this. We've been using splats. We've been talking about the remainders. But what happens if you actually have local variables and you want to actually pin and use those? So in this case, right, in these two examples, the code's totally the same, right? I've got an expectation that I've set to 5 in this case. And I'm going to pattern match against this. But notice that in the bottom code sample, I'm doing a variable pinning here, and that's with the caret. This is really critical because this allows us to pin the variable to the expectation, which is a value 5 in this case. So in the first upper evaluation, right, we're getting a match of 1. And that's because the expectation variable is being set to 1 in this case, the first position of the array. But in the bottom situation, right, we're getting an unmatched variable of 5 in this case. And the reason that's happening is because the expectation in this case is pinned to the value of 5 up above. But the case statement that we have is for 1 and 2. Well, 5 doesn't equal to 1 in this case. And so we get the unmatched situation in that case. You want to be really careful about this, by the way, because it can be almost too easy to accidentally have a local variable, but then use that same variable in your case expression and not realize that, oh crap, I'm actually using another variable there. Or actually in this. Yeah, go ahead, Joel.
Sorry, before you roll into the next slide, I'm curious, why do you think that they implemented this language feature? Because this seems like if you were to use this, you'd be actively acknowledging that you were doing something that wasn't great by with shadowing. Or am I misinterpreting this feature?
Yeah, that's a good question, Joel. I have not been in a situation where I've been using variable pinning like this, where I need to pull in a local variable like that. And so I don't actually have a good example. I don't have a good example of when to use this just yet. I'm still trying to figure this out myself, actually, just because of the tricky nature of it. Yep.
Look, if you were to print the expectation after the end, then it would be 5 in both cases, right?
No, actually, well, actually, yes, yes. I think you're right, Dan, because you've overwritten. Well, actually, no. We should Actually, here, let's take a break really quick and let's just confirm that. So let's test that. So here's our expectation. It's coming back. Oh, wait, actually, let me set the variable here too. I don't know if that's going to copy. Oh, it's not. Okay. It's still coming back as 1. So it overwrote. Expectation actually is overwritten at that point.
But if you print it now, I mean, my question is it scoped to that case statement, I guess?
Oops. Yeah.
Oh, yeah. So it does overwrite it. Wow. Okay.
Yep.
That
Yep.
seems like a foot gun for sure.
Yeah. Yeah.
Brooke,
And
I got a quick one on here. Just to test, take that case 1-2 and make it case 5-1-2, and will it match with the?
so you're saying,
Make that 5 or 5-2, something like that. And then set expectation to 5.
okay.
Sorry, yeah.
I'll have
yeah, expectation equals 5, and then run the case again.
Yeah.
Well,
So
I didn't, that Jet said it. The one actually, what I was really thinking about is in the second one where you're pinning it in the second in. Does the caret mean it's not going to assign that value, but it's going to match to that value?
Oh, it's going to match that value. You're right. So, oops, sorry. Shoot, I just lost my screen. Okay. So actually, let me just clear this. Let's actually set this up so it's a little bit easier, like what you're saying, Jeremy. And I'll put expectation 5, and then we'll just run this code here. There we go. And then, yeah.
Now say expectation equals 1. And then run the case statement again with the pinned expectation. Okay, so expectation was spelled wrong.
Oh.
For a T after the C, yeah.
Oops, 1.
Yeah. Okay. Yeah, the question I'm wondering is it matching on the 1, or is it assigning the value to the 1 there?
It's
matching on it.
It's matching on the 1 there. Yeah.
Yeah.
Okay, so that's what the pinning means, is match this value, don't assign this value.
Well,
correct.
It could match and assign. You wouldn't know because it matched.
Right. But you could test if you had two objects that were equivalent but had different object IDs. You could test.
Yeah.
Which might not be the thing to do right now, but that'll be something to play with in the future.
Yeah.
But so probably a good way to think about pinning is hopefully means match the value in this variable versus extract the value from the case statement into this variable.
Right. Yeah.
Okay.
But the flip side is dangerous too, right? Like Joel was saying, is that, yeah, you could overwrite your local variable if you're not careful. Yep.
Yeah, this seems like a Rubicop rule just waiting to be written.
Yes. And there's a few more I want to point out too a little bit later on, Joel. So yeah, good question. Thanks. Yeah. All right. So let me just kind of skip ahead just a little bit here. So we talked about the pinning and the matching. Yeah. Okay. So let's talk about something just a little bit more sophisticated and deal with a pattern, or sorry, a hash here in this case that actually has a kind of complex structure, semi-complex structure, right? So in this case, I'll walk you through this. We have a school and we have an array of schools, right? So in this case, we're coming with a match ID of 2. So how are we getting that? And let's kind of walk through this together. So the way that we're doing this, right, is we're setting the key school in this case, right? That's our key. We're going to go ahead and pin that in this case. So this is a little bit more of an advanced, well, kind of takes pinning to a different level here, which actually is kind of cool in this case versus what we were talking about before. But school is going to be pinned in this case. The value of school is going to be high in this case. That's set to the pinned school in this case. And the reason we're matching is because the second level here matches high in that case. And so we spit out the result, which is really kind of a nice way to sort of use the structure of your hash to get the pattern that you want and pull out the data that you need. Now, in this second example, though, here I have the same kind of data, except I only have one element in my array. So in this case, high is set to school like it was before. But the problem is that middle does not equal high. And so we get an unmatched situation. So I think that might kind of ease a little bit of the concern, maybe Joel and Jeremy, that you had there, just a little bit, where the pinning can kind of help in this case, I think, especially with when you're within a level like that. Granted, don't get me wrong, you could still overwrite your local variable. That is dangerous, but this is kind of neat.
The other thing on that one I would want to know is, if you don't have a school variable before the case statement, do you now have one after the case statement? Does that promote a school variable that is now visible in the parent scope after the case statement?
It'll
so like,
yes,
if you said put school after the end of case, would that value have high in it?
Yes, actually, here, let me just let's actually do this live.
Yeah.
And yes is the answer, but let me see. Yeah, there
okay,
you go, Jeremy.
Okay.
Yep.
So that those variables are promoted to the current closure, I guess, would probably be the right statement.
Yes.
Okay.
Yes. Let's see here. Let me go back to my. Okay, so we've talked about variable pinning and kind of more complex hashes or structures, data structures. The other thing I want to point out is you can also use guard clauses here too. So in this case, where we have both an array and a hash, we'll get a match in this case because we're doing an if. So we're not only checking the pattern in this case, but the middle, which is the middle position in this case. And this, by the way, works with unlesses, but I'm just going to show you the if guard clause in this case. We're matching middle to equal to peach, and so that's a match in this case. And the same thing in the situation down here in the hash where the color is black. As long as that equals the value that we're looking for, then we get a match in that case too. And I'll show you this a little bit later. I actually use this in some of my code that I'm doing to a nice effect that I like. Okay, so we've been talking about primitives for the most part, and I haven't talked about structs yet, but we're going to get into that in just a moment. But I want to show you how to teach your objects to also work for pattern matching too. And the way that we do that is we can just define a class in this case. As long as we have a deconstruct method that can deconstruct our class into an array, now we can pattern match against that, which is really nice. And for hash, if we want to support hashes, we can also deconstruct that too, just using the deconstruct keys method. That's all we need to do in order to teach our objects to be pattern matchable. So if we look at this a little bit more closely, the way this works is if we have a case statement expression here, we'll see that we get a match in this case. And the reason that's happening is because point in this case for the case has the two elements there, but it's being deconstructed into an array that it can pattern match against. So we're back to where we were looking before in all the previous slides, right? We just basically have an array in the end that we can pattern match against, which is pretty cool. Same thing for the hash pattern. In this case, I'm doing something a little bit more funky here where I have a key and then I have an endless array where I start with 0 and then I don't care how high it gets. But this also matches as well. And the reason we get away with that, in addition, is because deconstruct keys gets called in the case statement when it does the evaluation and gives us a hash that we can pattern match against, which is pretty neat. Now, I want to take this one step further though, and I want to talk about structs for a moment because this is pretty neat and kind of peculiar. But I want to highlight this deconstruct keys and deconstruct methods a little bit further. So let's say that we have a point here, same as before, but this time it's a struct, it's not a class. And because structs are primitives, they have deconstruct and deconstruct keys built in by default. So you don't have to do any extra work. But let's kind of walk through this together and show what happens here. So in this situation, right, we have a case and the point is just, two elements, 1 and 2. In this case, it's a match, right? Because we're the evaluation that we're doing on point here is against the pattern of point, and then I'm just doing a beginless array of 5 and 5. And so that totally matches. Now, the reason we get away with that is because we're dealing with the same type. There's something else I want to point out here too, which is just a little confusing, but I want to highlight this. It's kind of subtle, but kind of interesting, and something that we might actually want to have as a style guide within Rubicop is you'll notice that if I use the syntax of bracket or parentheses for point, this would also match. This is syntactically correct as well, because the way that Ruby cares about this is it just cares for a constant in parentheses and then a pattern. The reason I'm using brackets there is because I've been doing that for arrays in general throughout this entire slides, but we could use parens, and I almost kind of think we should, because it's a little misleading if you know structs really well, is that if you have a struct, you can initialize it using the bracket hash syntax. You don't have to type new to new up a struct. And so this can get a little confusing from a pattern matching standpoint. That's why I'm highlighting the syntactical difference there. In this next example, this will also match as well, where because the point deconstructs to an array, we can also match against an array. And I just happen to, again, have a beginless array in this case. And so it matches just fine. Because we're dealing with the same type. It's still an array that's being deconstructed here. Now, in this situation, though, this won't match. And so I want to talk about this just a little bit, because when I was showing you earlier that we care about the type, this is really subtle, but very powerful, which the case that expression that we're matching against is the array of 1 and 2. And you might think, hey, point evaluates it'll fit in that pattern, right? Well, no, it won't, because the case statement is on an array, but the type that we have here is a point object. It's a struct. So they're not the same type. And so it doesn't match at all. This is really powerful and really kind of cool. It really made me take a step back and think about like the power of this in terms of the type matching that we get with that, especially with complex objects like struct. Well, structs are semi-complex, but your own custom code, right? This is really neat to be aware of. One other thing, just to highlight this just a little bit further, just to kind of let this sink in a little bit more, is if I have a struct and I'm actually doing it with a hash in this case, a hash in this case, this totally works too. And again, I'm highlighting the syntax of the parentheses here. I think we might actually want to write our code that way just to show that the pattern in the in statement here matches because we only care about the pattern, the type, and the keys that are in it for the array. But it doesn't mean that we're dealing with a struct in this case, right? It's just a pattern. So anyway, just wanted to highlight that if that helps. So let's talk about a few examples here and kind of where I'm using this and kind of show you where I've been so far. I want to talk about Rubysmith a little bit. It's just a gem that I have. It's open source. You can download and install it. It just helps you build a Ruby project so you can get off the ground up and running with all the tools you need. It's a nice way to just demo things, share with friends, write something up and send it over to your colleague because you want them to toy with some lightweight Ruby code. This is a nice way to do that. I won't go into all the details here, but if you run Rubysmith from the command line, you'll get this kind of output, right? Now, you don't need to know all of what's happening here, but I want to focus in on these 4 commands right here that you can pass into Rubysmith, because I want to show you how I'm using the option parser, which is native to Ruby, one of the core libraries, and I'm using pattern matching to basically figure out what command you're sending to Rubysmith so that I can parse it and do the work that you want me to do. So the way that works is if we look at this code here, I'll walk you through this, and I've truncated this down a little bit. So there's some implementation here that I've ripped out and thrown off screen because I just want to focus on the pattern matching to kind of highlight this for you. So in the call here for my shell, I'm taking those arguments that you saw on the previous screen, right? I'm crunching those, running them through option parser, figuring out what's been parsed, and then I'm going to do a pattern match on those options, right? So here I can see like, hey, did you give me a config command? Great. I'm going to go ahead and send it off and process that config here, as you can see in this method down here, this private method. By the way, I'm using endless methods here. So if you haven't seen this in Ruby 3.0 syntax, that's why the methods have equal signs and they're all one line. So just highlighting that fact. I actually, at first, I wasn't sure about endless methods, but I'm actually finding that I really enjoy this quite a bit. The conciseness of my code is pretty sweet. In this case, right, if I get a build minimum or a build, I'm just going to send them to the same private method in this case, right, and have it process that data. In the case of version and help, I'm just going to print out the version info or the help information, and I'm just sending it to the option parser in that case. Again, don't worry about the details of the option parser and all the other stuff I'm doing here. I just wanted to show how sweet and concise this is using pattern matching to basically process that information that's coming from the command line and do something interesting with it. So let me show you another example, just in case it helps highlight this a little bit further. There is a deployer project that I'm working on. It's internal at the moment, but I'm also trying to open source this and provide benefit for others in case they need this kind of problem solved as well. I know Joel might laugh at me just a little bit because I know that GitHub uses Hubot and has a pretty sophisticated deploy process and everything. And so this is my lightweight kind of version of that. So bear with me, Joel. But with deployer, it's a Slack bot. You can talk to it and here's the commands that it processes. But what I want to highlight to you is notice that in the / command of deployer, we can ask it for the status of our project. We can ask it to version the project and we can get some help. And what I want to show is how to process information coming in from Slack and using pattern matching to do that. So what this looks like in the deployer code is very similar to what you saw in Rubysmith. And again, don't worry about all the details of this, but let me just kind of point out the data coming in. So in the case of the data coming in, we have text and we're going to split it, right? And we're splitting it by spaces. So those commands that you're typing in Slack, I just split those into an array and then I pattern match against them. But what I'm doing is I'm looking for strings. They must be, I'm very critical, they must be of the right type. And then I assign those to an action variable, and then I can do something interesting with it. So in the case of help, I just spit out help information back to the user. In the case of notes, I'm going to go ahead and build up the status, and I'm using some monadic patterns in here to answer a response back to the user. But I can process that as well. And in the case of the situation where the person wants to actually publish a version of their project, then I process it here and I do some, version name type stuff and send that on down. And in the very last case, right, the else situation where somebody sends me in a whole bunch of gibberish through the Slack command, I don't even know what to do with that. So what I'll do is I'll just say, hey, sorry, please try to run, deployer help, the / command deployer help, and I'll just show you that helpful information again so you can figure out how to send me a better message. So again, kind of a real world example of how pattern matching is really nice in that kind of situation. So to kind of sum this up, right, just a few things that we've kind of talked about here and some guidelines that I want to highlight is when you're dealing with arrays, right, remember to sort them before you go through and pattern match against them. In the case of limited finds, when you're doing those finds, right, make sure that you keep that usage limited. Not only is it experimental, but it is actually expensive to actually filter something out within the details of your array. Avoid unnecessary deconstruction if you can. And what I mean by that is, when I showed you that point class, right, that's pretty simple. It has an X and Y coordinate and you're dealing with mapping information. But if you have objects that don't make sense to be deconstructed into an array or hash, please don't do that. You probably need another object or some other kind of encapsulation there that would be better suited that you could use pattern matching against. So don't try to pigeonhole your objects into this kind of pattern matching syntax if you don't need to do it. The other thing too is be very careful about shadow variables or any of the kind of situations that we're kind of coding together and live coding there when I was in the shell, because there are some negative side effects to that. And again, be careful with nested patterns. it's very easy to take a very complex nested hash and do a really complex pattern against it. But in these examples that I've been showing you today, they've all been pretty simple, right? But if you imagine a complex hash and then a complex pattern to follow that out, it's going to be really hard for you to maintain, also hard for you to read. And I would consider maybe extracting that out or chunking that into smaller bits of work if you have to get into that kind of level of unraveling a nested structure. And that's it. That's kind of Ruby pattern matching in a nutshell, and kind of a high level, but I hope that gives you a ton of information in which to kind of go out and add some of that to your code and play with it. I'd also be very interested in learning what people are doing with pattern matching. So if you ever want to post in Slack, in our Ruby Friends Slack channel, or just hit me up directly, I'd be very interested, because I think there's some really cool things that we can do with our applications. And I'd love to see the various interesting ways that people are using that. So anyway, that's my presentation. And if there's any questions, I'm totally happy to answer anything.
Awesome. Thank you, Brooke. That was a great tour. Does anyone have any questions for him?
Yeah, I have a question. Brooke, as you were talking, me and a friend were like madly Googling like what is pattern matching because we didn't have any experience with it yet. And we found that it's mostly in like functional languages, like Elixir and stuff like that. And I was curious, like, what do you think like had the Ruby community be like, this is important enough for us to like include it in our language?
Yeah, so well, there's a lot of cases like I was showing you there where that kind of comes in to play, right? That you can add to your code that we didn't have before, right? It'd be more complex to do like traditional control flow or if then else statements that would make it a little bit more complicated. But it does. It gives us the ability that we've seen. Like I don't have any slides or examples to point you to, but in Elixir, they actually have a lot of pattern matching built in, and they do some really cool things with like, they actually have pattern matching where with your methods, you can pattern match against to figure out how to process data coming in. I'm not an Elixir expert myself. In fact, I actually haven't written any Elixir, but I know that that's being used there. Maybe I might pause for just a moment. I know that Marty's here, and I think Marty's done some Elixir. So maybe Marty, not to put you on the spot, but maybe you can speak to that just a little bit too.
Yeah, I mean, I think with pattern matching, if you think about, well, I mean, if you've written a lot of code where you're trying to, route logic, conditional logic through your program, pattern matching allows you a more concise way to do that. And for the languages that implement it, it can be very efficient as well. So that's sort of like my take on it. Because like before I was writing in a language that had pattern matching, I would do pattern matching in a less efficient, uglier way, like depending on how you're doing a case or you're doing a lot of if, else, if type stuff, because ultimately you're doing similar things. And so pattern matching just allows you a more concise way to do that. That's really readable. And like you think about the example of like what Brooke showed with his options parsing, like that's great. Like you can read that and like, I totally get that. Where imagine if you had to do if, else, if for that across, it'd be a lot more code, it'd be harder to read. So
Totally. Cool. Thank you.
Yeah, I do a lot of pipeline data processing, and so the data you come across is basically a whole ton of hashes, but sometimes fields are missing, sometimes fields are not there. So I'm probably at some point going to be using pattern matching to say, okay, all the messages that come across that match this set of fields, having these keys gets this routing versus this set of keys gets a different routing, and ones that are maybe missing some keys get thrown out for bad data. That's going to be probably one of my main uses for pattern matching down the road.
Yeah, and I wish I had time to I wanted to try to slip in some time to actually show that from processing an incoming API, because I'm also interested in that too, Jeremy, especially when you're dealing with third-party APIs. So some people might chuckle, but if you've ever had to do third-party API integration, sometimes the third-party integrations that you're dealing with, they don't actually even understand how to write APIs properly. And so they'll send you back a gibberish bunch of data that is just, it's a nightmare to deal with. And so with pattern matching, we could have a better way to actually process that, transform that data into something that's clean for us to use internally, and kind of have that corrosion layer, so that we keep the bad data that's coming in from outside, right? Not corroding and corrupting the data that's inside, the data that we own and that we're processing. And this would give us a nice way to do that.
Cool. All right. Well, if there's no more questions, I think we can wrap things up. Rylan, you want to take us home?
No, I don't want to take you home, but I can take you out of here. So thank you everyone for coming. You do not have to go home, but you cannot stay here. We are shutting this down. Thank you both of our speakers. That was amazing. Really appreciate your input and time. And just adding to the community is just a huge, huge value add. And so we really, really appreciate it. And I think it kind of helps all of us feel a little normal to be able to still do this. So thanks again, and everyone have a great night.